Welcome everyone to the community conference. Today we're going to talk about how you can save space and speed up your queries, and that even for free, or the more boring title, the data stream naming scheme. So let's jump into it. So first, quick introduction. Alex already told you, my name is Nicolas Ruflin. I'm based in Switzerland. I'm the tech lead of the data collection team. So basically, I'm working on the observability front at Elastic, currently at the Flea project. Adrien?
Sure, and I am Adrien. I also work at Elastic, where I'm a tech lead on Elasticsearch, and I work on things like indexing, search, aggregations, or mappings. I happen to be based in France. That's me.
Thanks. So let's dive in. So what we're going to do today. So first, quick introduction, why we do a data stream naming scheme and what is a data stream. Then Adrien is going to dive into the technical details. So our goal today is really that you understand why we did it and how we did it, so you can use it yourself. And in the end, I'm going to give you a quick demo on the Fleet project, which uses this new naming scheme, so you can see it in action. So about our promise, save space and speed up search for free. Have you ever asked yourself, how could you take your existing data, your existing indices, structure them differently, and have better search performance, use less space, which likely means less storage? So that's what we're going to talk about, and we hope what we're going to show you, you can apply to your data too. So first, why a data stream naming scheme? I mean, there are many ways already to index data, but the one I'm initially going to talk about is the past indexing strategy. I worked a lot on beats. Was with beats, we had file beat dash star, metric beat dash star, basically all logs, all metrics went into a single index. Beats loaded all the assets like index template, island policy. Let's say it worked. But there were a few problems, and I'm showing these problems not only related to the beats indexing strategy, but I'm pretty sure a few of you will also have encountered these problems with your own indices. You had too many fields in a single index, which caused problem. There's a soft limit of 1024. Or you had all your logs together or metrics together in a single index, and you're like, my Nginx logs should not have the same retention as my security logs from my Cisco firewall. Another problem is maybe your query always had very similar filters. So you always had to query on the whole data, even though you only wanted to look at the section, for example. You only want to have the access logs of Nginx, or you only want to have query for the CPU metrics and not the memory in one go. Another issue always was around how do you set up? You want to have an alias with indices behind it, but you had to make sure that the whole setup was done before you started to ship data. And one challenge specifically we had, you probably had that less because you defined your indexing strategy, is as soon as someone started to modify file beat dash star, metric beat dash star, and used foo dash star or added a thing in the middle, things started to break because we had a lot of optimization around this. So let's go forward and see a bit how we solve this problem, and let's talk about the data stream naming scheme. So first, the elephant in the room. What is a data stream? I hope quite a few of you have heard of data streams by now, but it is a new concept introduced in 7.9 in Elasticsearch, and Adrien is going to dive deeper in what it is on the technical side. But for the next slide, just think of it as an index that is optimized and purpose-built for time series data, and it's very similar to an alias with indices behind it. So what is that data stream naming scheme? So when we built the Fleet project, we wanted to solve the issues we had with the past indexing. So we said in general, we have data that consists of three parts. The first part is we know the type. The type for us is very generic. Is it logs? Is it metrics? Is it a trace or is it synthetics? So that is the type of the data. And that allows you first to just query for logs or metrics. The next one is what we call data set. And some that use beats probably know event data set. So the data set describes the structure and the mapping of the data. So for example, Nginx success logs have the same structure. Nginx error logs have a different structure, but all the Nginx error logs have the same structure. And the last part, which we call namespace, is basically is a user configurable part. You can think of it as prod, as testing, team 1, team 2. So we built that in, that there is a user configurable part. So in short, that is our data stream naming scheme. There's a type dash dataset dash namespace. So take an example is logs dash nginx.access dash default. And if you actually didn't know what your data set or what your namespace is, just ship it to logs dash generic dash default. So this very basic concept, defining the type, the data set, and the namespace for your data, in most cases, just use default namespace. You're going to use automatically the new data stream naming scheme. Keep in mind, it needs to be one of these 4 types. So there are a few other things that are important with the new naming scheme. And one is bootstrapping of templates. So the first thing is there are generic templates loaded by Elasticsearch for logs, for metrics, for traces. And what it does, it means you actually don't need to think about the templates at first on your end. You're going to ingest data. It automatically going to have ECS-based mapping for all your data. And if you go further, you can actually then specify fields based for the data set. Nginx.access star, for example, is going to load the ingest pipeline you can attach to that data stream. So this structure can be used by you as a user to put in templates, more specific ones, and have actually the ingest pipeline defined on the centrally, and it's used by the Fleet project. So we load everything, all the assets in that structure. And unfortunately, we don't have enough time today to go in all details, how the templates look and everything. But basically, if you use this structure and you're going to see that structure in the demo, things are just going to work. So what do you get with that data stream naming scheme? So first, you reduce the number of fields per index because you specify a data set for your data. Only the data with the same mapping goes into the same index. The next part is, because you have a data stream per data set, per name stream, you get much more granular control about your data. You can specify security, you can specify ILM, all on that specific data stream. You also get more flexibility on how you work with your data. What I said before, when you delete it, what do you query? What it allows on our end is to give you a better curated experience because we know all your data is following that schema. We can actually do magic on top of that. Like we know all the logs are there, all the metrics are there. We know there is a namespace section. So it allows us to help you and help us to build a better experience on top of it. And the last part, I mentioned before, the whole setup is happening centrally. Before ingestion, Elasticsearch loads the templates for you, the base templates. So you actually don't need on your edge machine something that's set up Elasticsearch because the permissions only need to be centrally, and actually on ingest time, you just append data. No index template, no ingest pipelines, everything is central. If you modify an ingest pipeline, you do it in a central place. So there was one problem with everything I presented you right now is when we actually figured out that's what we want to do, we realized Elasticsearch didn't have all the features. But thanks to Adrien and team, they were built. The features were constant keywords, composable index templates, and data streams. And that's exactly what Adrien is now going to talk about. You're going to see all that. Keep in mind that schema and what Adrien is going to talk about. I'm going to show it in the demo in the end. Please take it on, Adrien.
Thank you, Nicolas. So let's not talk about the technical details. So Nicolas already gave you a bunch of information about that new data stream naming scheme. And there are two parts that are important. The first one is the new features that we added, which include data streams, composable templates, constant keyword fields. And the second part is a new convention, how to name data streams. So let's first start with the features we introduced. So data streams, they are a formalization of time-based indices. If you've been with the Elastic Stack for a long time, you probably remember the early days when we are using time-based indices, where indices simply had the current date in their name. Then we moved to indices that would roll over on a regular basis based on their size or age. And this second approach addressed the previous problem of the time-based indices approach, which is that you could not reason about the size of the indices you produce. They would always be daily indices. And it turns that in some cases, it's better to have fixed size indices, say 50 gigabytes indices, and that's where the rollover action helps. And moving to data streams is something that helps move forward again with and address some issues that we had with the previous approaches. So the previous approach that uses aliases had a big issue that we refer to as the bootstrapping problem that I'm going to dive into in the next slide. And data streams also bring other benefits. First, they define a timestamp field. That's very useful because then, say, from Kibana or any client that queries Elasticsearch, when you're dealing with a data stream rather than regular index, you know that you're working with time-based data. And that's something that helps us build better user experiences. It's also something that's useful from within Elasticsearch. We started adding new optimizations that work better with time-based, with data streams that are time-based. For instance, when you're looking for the most recent hits by timestamp or by timestamp, for instance, we are not going to look at all indices equally, all indices behind the data stream, I mean. We are going to look first at the indices that have been created last because they're the most likely to have recent data. Data streams have built-in ILM integration. So every ILM action is a first-class citizen for data streams. And data streams can be composed thanks to composable index templates. So for instance, say you're going to ingest Nginx logs. There might be parts of the structure of those logs that you can define in templates that general to all the logs you're going to index. There are parts like some of the fields that are going to be specific for Nginx, and maybe some of the fields are going to be specific to the dev environment that you're going to be collecting data from. So these are things you can do with composable index templates. Next slide, please. Yeah. So what's that bootstrapping problem that I mentioned? If you were familiar with this way of working with time-based data, where you have an alias with multiple backing indices, and regularly the role of action would move the alias to a new index in order to try to have fixed size indices behind your, it wasn't formally a data stream at the time, but let's call it that way. The issue we had with that is that you had to configure that alias first before starting sending any data. And that was a big issue with user experience because you had to know what data streams you were going to index data into before actually sending data, which is not always possible or not always desirable. And so we had to find a way to address that issue. And the way that we addressed that issue was thanks to the introduction of data streams on the one hand, and in the introduction of composable index templates on the other hand. You can configure composable index templates to tell Elasticsearch that all indices that match a given pattern, something like logs -star, should actually not be created as indices when they are created automatically through the ingestion of data, but they should be created as a data stream which is the thing you need because you're going to ingest time-based data. And that's very important, because if you made the mistake of starting ingesting data without configuring an index template so that the index would be created as a data stream rather than, if you didn't configure Elasticsearch so that the data stream would be actually created as a data stream and not an index, then you would end up with an index that would infinitely grow without an easy fix for that problem. So that's the point of composable index templates. Next slide, please. So that's about the technical part. Now let's talk about the convention. Before, like Nicolas described, we used to have one set of indices for logs, the file bit dash star indices, and one set of indices for metrics dash star indices. And this has a number of issues that we'll dig into later. So what have we changed? We've changed it so that we would create a different data stream per type of data. Logs and metrics end up in different data streams. Per data set, Nginx logs and security logs end up in different data streams, as well as different namespaces. So production logs and development environment logs are going to end up in different data streams. That has many benefits. In particular, you can configure the retention more easily, like Nicolas described. Can you come back to the slides, Nicolas? Perfect, thank you. So we have easier ingest integration, like Nicolas described. We have easier and better security. Nicolas already mentioned the ingest side part of the security, but that's also true for the search side part of the security. Like for instance, if you want some users to have access to your Nginx logs, but not to your security logs, in the past, you had to configure this through document level security because all documents were part of the same set of indices. Now, due to the fact that security logs and Nginx logs would end up in different data streams, you can actually configure that sort of security through index level permissions, which is easier and more efficient. Split data streams are smaller and they're faster. And those are two parts that you're likely very interested in that we're going to dig into now. So can you go to the next slide, please? So we've been looking at a data set of metrics, and here you can see the distribution of the types of data we have in that data set, but that's not the thing you're interested in. What you're interested in is the next slide, where we built a comparison in terms of size, indexing, performance, and memory usage for the old indexing strategy, where all metrics would end up in the same indices, versus a new data stream naming scheme, where each data set ends up in a different set of indices. And as you can see, memory usage is a bit better, indexing throughput is a bit better, but what's actually very different is disk usage, which is very significantly slower. And what's the magic behind this? Why did it help? The reason it helps is that all parts of the Lucene indices are compressed, and most of the compression algorithms we're using, they like consistent data much better. If you have a mix of Nginx process metrics, memory metrics, CPU metrics, that's much harder to compress than if you only have CPU metrics, because in the latter case, there is so much more redundancy, which is something that compression algorithms like. It's much easier to achieve a high compression ratio. So splitting data by dataset actually helps compression a lot, because then instead of having blocks of data where you end up with very different types of data that are hard to compress because there's not much redundancy, you end up with consistently the same documents that have the same structure and only vary on the basis of a few fields. And that's something that's very easy to compress. And that's the reason why you're seeing better compression here. And that technique that we are really seeing via Fleet and that becomes the default is something that you can also apply to your own data to get similar benefits. We are giving an example here with metrics, but you would actually get the same sort of benefits with logs or any kind of data as soon as you try to partition your data so that the similar data ends up in similar indices. So can match and steroids. So what's can match? Can match is a feature we introduced for timestamp fields so that if you query a narrow range of timestamp, something like the last 7 days, then we would efficiently skip indices that are older than 7 days. And we've generalized this approach so that it would also work on a new field type that's called constant keyword, so that we would skip indices that don't have the right value for that constant keyword field. And that constant keyword is a field type we're now using for the data stream type, dataset, and namespace. Can we go to the next slide that explains how it works? So here's how it works. Say you're an Elasticsearch coordinating node that needs to execute the filter that's displayed on the slide. So a term filter on the dataset field that looks for the MySQL status value. So Elasticsearch is going to go to all your shards and perform a can match phase. Is there potential for a match for this filter on this index? And when it goes to the MySQL status dataset, that yes, indeed, there might be a match because that's the value I'm looking for. But when you go to the nginx logs, there's no possibility to have a match because that constant keyword field that needs to be the same across the entire index doesn't have the expected value. It has nginx.access as a dataset rather than MySQL.status. Next slide, please. So Elasticsearch is not even going to try to run the query on that index. It's simply going to ignore it. And that way it runs much faster than if you had run the same query on a monolithic metric bit or file bit index. Next slide, please. Field suggestions, why am I bringing that up? Because in the past, when you had monolithic file bit or metric bit indices, it was very hard to build good field suggestions because there was no way to figure out what fields would be relevant for a specific set of data without actually looking at all the documents that match your filter. And now that we have that can match phase and that constant keyword field and have that new data stream naming scheme with every data set in a different set of indices, we can look at your filter, see which indices it would exclude, and only build recommendations based on the indices that would match those term filters on constant keyword fields. So you're no longer going to get suggestions with thousands of fields. We are very soon going to be able to provide you with much relevant field suggestions in Kibana for your time-based data, even if you have terabytes of data in your indices. So what's the catch? What's the downside? We've been talking about the new benefits of this new approach. You get better control over the retention, you get better space efficiency, you get better memory efficiency, and indexing throughput. So what's the downside? The downside is really for low volume data sets because you have two choices, either you rollover on size. For instance, you configure rollover to rollover after 50 gigabytes. And if you have a low volume data stream, then you're going to end up with months-old data in the hot tier. And that's not good because not only are you going to end up with months-old data in the hot tier, but it's going to take several weeks then to migrate to the warm tier, even after it's reached the minimum age for the warm tier. So that's not a good user experience. And that's an option we discarded. Either you roll over based on age, something like let's roll over every 1 day, 2 days, 7 days, but then you're going to end up with more shards that are going to be smaller on average. And Elasticsearch doesn't like, Elasticsearch tends to like large shards better than smaller shards. And that's the reason why one of the main initiatives in the Elasticsearch team these days is to make Elasticsearch better cope with smaller indices. And that's it.
Great. Thanks, Adrien. I think we're already on top of the time, so David is probably going to cut us off. David, can you jump in to say if I can still do the demo or too late?
How long will it take, Nicolas?
I'll make it 1 minute.
Yeah, that is fine. Let's go for it.
Yeah. So cool. I'll shorten the demo and let the demo docs with me. So what I have is an Elastic Cloud cluster, and I have on the side an Elastic agent running on top of Fleet. Fleet is that project that you have a single agent and it ingests data, you can manage it centrally. And the tab that is really interesting here is the data streams. So you see everything is split up into type, dataset, namespace. I think now that rings a bell. And if we look at the metrics dashboard, metrics system overview, that is really what I want to show you. Is this is running on my machine right now. So previously, if you have metric beat, every single block on that dashboard was actually running across all the data constantly. And now, because we query on datastream.dataset, actually each block here only runs on the data that is really needed. So it pre-queries it and knows exactly where the data is. So instead of having all the metric data for each block here, it's only what it needs. So that already shows why it's going to be so much faster to load that dashboard now with ElasticSearch and the data stream naming scheme than before. So yeah, as we run out of time, I'll stop the demo here, but I hope that showed you a bit on how it works.